Hello, so today I wanted to continue our study of systems of equations by doing a quick little lesson on solving systems of equations by the elimination method. So the elimination method is a method that we can use to solve systems that often works really well where substitution would be really messy and we would end up with lots of really annoying fractions. So let's start with just an example. So suppose we have the system of equations, let's say ax minus 7y is equal to 64. Then suppose we have 2x plus 7y is equal to 18. So if we wanted to solve this by substitution, it would be very possible to do so, but we would very likely end up with some annoying fractions because of the presence of this 7 here. So there's a better way to solve this equation, and that is using elimination. And how we would do that is we'd actually apply our old friend from Unit 1, the addition and subtraction properties. So the addition property, if we can recall, tells us that if A is equal to B, then A plus C is equal to B plus C, where A, B, and C are real numbers. So what that tells us in this situation is if this is equal to this, and this is equal to this, then that means that this plus this has to be equal to this plus this. So let's go through that again. So we're essentially calling this A and this B. And then since these are equivalent, we can call both of them C. And then, if we apply this property, we can add these two equations, and we get 8x plus 2x is equal to 10x. And here's where the really cool part happens, is we have negative 7y up here and positive 7y over there. So what's negative 7y plus positive 7y? It's 0. It's like magic. And then 64 plus 18 would be 82. So now we have a simple equation with just one variable in it. And this is why the process is called elimination, because we eliminated y as a variable. So now in order to solve the equation, we divide each side by 10. We get x is equal to 82 over 10, or if we simplify that, x is equal to 41 over 5, which would be our final answer for x. Note, we're not done yet. Recall from our last couple lessons that the solution to a system of equations has both an x and a y coordinate. So in order to get the y coordinate, we have to put our x value back into one of these two equations. So I'm just going to pick this one just for convenience. So we get 2 times 41 over 5, which is our answer from there, plus 7y is equal to 18. And notice, again, now the x is gone, and we just have a y. So 2 times 41 over 5 is equal to 82 over 5. And if we subtract 18 from this side and subtract 7y from that side, we get this as our answer. 18, if we turn this into a fraction, we would get 82 over 5 minus, let's see, 90 over 5 would be equal to 18, is equal to negative 7y. And if we take this up here, we get 82 minus 90 over 5 would be negative 8 over 5 is equal to negative 7y. And then if we divide each side by -1/7, we get 8/35 is equal to y. And we could either just leave our answer like that, or we could write it as a coordinate pair. And we would get 41/5, 8/35. So you see, even though we did have to deal with some annoying fractions, at least the first part, it was very easy to just say, okay, we're going to add these two equations, and the term with the y in it just disappears like magic. So let's do another slightly more complicated example. So when we solve an equation using substitution, using elimination, sorry, it's not always that easy to get started. Suppose we have 2y plus 4x is equal to 4, and suppose we have, let's say, 3y minus 8x is equal to -12. So you notice here, we can't simply just add these equations and have a variable disappear. That's not going to happen. So sometimes we need to use the multiplication property. So if we recall, the multiplication property tells us that if A is equal to B, then A times C is equal to B times C. So notice, if we multiply both sides of the top equation by 2, and I'm going to move this equation down here, we get 4y plus 8x is equal to 8. So since we multiplied this equation by 2, now we have a -8x and a positive 8x. So what does this mean? This means that if we add these equations together, we're going to get 7y, these terms will cancel each other out, is equal to -4. So we were still able to use elimination, we just had to start by multiplying the top equation by 2 so that we had these two terms that would cancel out. And with more practice with systems of equations, you'll develop an intuition for first, okay, would it make more sense to solve this equation using substitution or elimination? And also, within using the elimination method, you'll get a sense of, oh, okay, I need to multiply this equation by 2 because then these two terms will cancel out. And lots of times there are many ways to skin the beast. Like, for example, we could have multiplied this top equation by -3 and this bottom equation by 2, and then we would have been able to eliminate the y term. But I guess since I've been doing this for a while, I was able to notice, hey, it would be simpler if we just multiply the top equation by 2, and then this term will cancel out. So again, we'll go further. If we divide each side by 7, we get y is equal to -4/7. And now let's plug our answer. We could plug it into either of these two equations. Looks like it'll be a little bit easier if we plug it into the top one. So we get 2. And then again, substitution method, y is equal to -4/7 plus 4x is equal to 4. So 2 times -4/7 is equal to -8/7 plus 4x is equal to 4. We're going to squiggle around over here. If we add 8/7 to each side, we will get 4x is equal to 4 plus 8/7. So I'll step aside just so that you can see that step quickly. 4, if we got a common denominator with 8 over 7, we would get 4x is equal to, so I'll multiply by 7, 28 over 7 plus 8 over 7, so we get 4x is equal to 36 over 7. We divide each side by 4, divide by 4, we would get x is equal to 36 over 28, which is also equal to 18 over 14, which is also going to be equal to 9 over 7. So again, we can leave our answer like this, or we can write it as a coordinate pair. So 9 over 7 will come first, and then -4 over 7 will come next. So those are just two quick examples of how to solve systems of equations using the elimination method. I'd be happy to answer any further questions during class or do more examples on the board.